So let's read the question. L and M are two parallel lines. So L and M are two parallel lines intersected by another pair of parallel lines P and Q. So we have two pairs of parallel lines, L and M and P and Q. Now we have to show that triangle ABC is congruent to triangle CDA. So let's begin. So first step is understand what is given to you. See, these two lines are parallel, these two lines are parallel. Based on this, we have to show this triangle is congruent to this triangle. So how do we do it? See, the moment I see parallel lines, what do I know? Parallel lines search for a transversal. So for these two parallel lines, AC is a transversal. Similarly, for these two parallel lines, again AC is a transversal. I repeat, for these two parallel lines, AC is a transversal. Similarly, for these two parallel lines, AC is a transversal, right? Now, whenever I have parallel lines as a transversal, what do I know? Corresponding angles are equal, alternate interior angles are equal, and interior angles on the same side of the transversal are supplementary. So what do I have over here? First, check for alternate interior angles. So see, look at lines L and M. AC is the transversal. So this over here is equal to this. See, these are two alternate interior angles. They are between the two lines, so interior angles. One is on the right side of the transversal, others on the left side of the transversal. So what are these two angles? Alternate interior angles. Similarly, I want you to look at lines P and Q. Again, AC is a transversal. So again, this angle over here is equal to this angle over here. See, what are interior angles between the two lines? Alternate means one on one side of the transversal, other on the other side. So these two angles are equal, alternate interior angles. These two angles are equal, alternate interior angles. Next, this side over here is a common side. So in two triangles, if two corresponding angles are equal and the included side is also equal, the two triangles are congruent. Which criteria? Angle, side, angle criteria. So by ASA criteria, they're congruent. So let's write it down. So taking lines L and M and AC is the transversal. So this angle is equal to this angle. What is this angle over here? Angle DAC. So angle DAC is equal to this angle over here, angle BCA. What is the reason? Alternate interior angles. So mention it. Similarly, take lines P and Q. So we have this angle is equal to this angle, that is C. First of all, we begin with angle DAC. Angle DAC is of this triangle. So again, take this triangle. So angle DCA is equal to this angle over here, that is angle BAC. What is the reason? Same, alternate interior angles. So now what do we observe? These two corresponding angles are equal. Next, AC is the common side. So now come to these two triangles, that is in triangle ABC and triangle, which are the triangle? Triangle CDA. So first of all, this angle is equal to this angle, write it over here. So that is angle BAC is equal to angle DCA. So you can call this over here, let's say we call this over here 1 and we call this over here as 2. So you can mention from 2. Similarly, this over here, angle BCA is equal to angle DAC. Notice first the parts of this triangle, then the parts of this triangle. From where are we getting this? From 1. And next, AC is the common side. So AC is equal to AC. What is the reason? Common side. So mention in bracket common side. So what do we observe? In two triangles, two corresponding angles are equal and the included side is also equal. So ASA criteria. So the two triangles are congruent and we don't have to worry about the congruence statement. Why? It is given to us over here. So therefore, triangle ABC is congruent to triangle CDA. What is the reason? ASA criteria. Angle, side, angle. So you can mention over here ASA congruence rule. So hence we have shown the two triangles are congruent. So you can write over here, hence proved. Pretty simple, right? So remember, see, the first step is always look at a figure. The moment you see two parallel lines, look for a transversal AC. Whenever I have two parallel lines in a transversal, apply the concept of corresponding angles are equal, alternate interior angles are equal, or interior angles on the same side of the transversal are supplementary. Normally in the case of triangles, it's alternate interior angles is equal. So search for alternate interior angles. How do we search? It is the angle formed between the line and transversal here. Same angle between another parallel line and the same transversal. See, what is this angle? Line and transversal. What is this angle? Line and transversal. So these are equal. Similarly for these two cases, angle between line and transversal. Here angle between line and transversal. So alternate interior angles are equal and the common side. So two corresponding angles are equal and the included side is equal. So angle, side, angle. So by ASA criteria, these two triangles are congruent, right? So remember, the moment you see two parallel lines and transversal, apply these concepts, mark your angles as equal, see which sides are equal, you'll get the answer. It's very, very simple, right? So this is how you solve this question.